All right, for this lesson, we're going to take a look at geometric series. Geometric series works the exact same way that arithmetic series did. It's just taking the terms of the sequence and then we're adding them together to find the sum of any given point. In a geometric series of n terms, my sum would be the first term plus the next term plus the next term plus the next term plus the next term, going on and on forever. So we can write this in two ways. We can either say that the sum is equal to the value of the first term times the common ratio to the power of the number of terms minus 1 over the common ratio minus 1. Or if I know the value of the last term, I can say that the sum of the terms is equal to the common ratio times the last term minus the value of the first term divided by the common ratio minus 1. For example 1, it says show how to develop the formula. You don't need to know how to develop the formula. Both those formulas in both their forms are in your formula sheet. Just need to know how to use them. You don't need to know how to create them. So jumping ahead to example 2, determine the sum of the first 15 terms of this sequence. Well, I know that in the sequence, term 1 is equal to -5. The common ratio is equal to term 2 divided by term 1, or -2. And then, because I don't know the value of the last term, because of this ellipses at the end, I'm going to use the formula that does not include the last term. I'm going to use Sn is equal to term 1 times r to the power of n minus 1, all divided by r minus 1. And we do know that it says first 15 terms, so my n is going to be 15 when I do it in this formula. I'm going to sub in my values and say that my Sn, or S15, is equal to -5 times -2 to the power of 15 minus 1, all divided by -2 minus 1. And the big thing here is making sure that you're using the brackets and putting it into your calculator properly. If you did it properly, you should have got the value of -54,615. For example 3, same process, but in this case, we know the value of the last term. We just don't know how many terms there are in the sequence. Now, the nice thing is when we take a look at that form of our equation, unlike in our arithmetic series, where in every case we need to know how many terms there were, in this case, you don't need to know the number of terms. You don't actually need to know the n value as long as you know the first term, the last term, and you can find the common ratio. So I'm going to say that T1 is 4, Tn is -8748, remembering that the sign beside the term does matter, and that the r value is -12 divided by 4, or -3. At this point, I can say that my Sn is equal to my r value times my final term, 8748, minus my first term, which is just 4, all divided by my r value of -3 minus 1. And when I plug this in properly, I get -6,560. For example 4, it says the sum of a certain number of terms in the series is going to be -104,858. What is the last term that would make up this series? Well, what do I know? I know that my T1 is -2. I know that my common ratio is 8 over -2, or -4. I know the sum of however many terms is -104,858, and I'm trying to solve for what my Tn is. Because what I'm trying to solve is my Tn, and I have these three other pieces of information, I'm going to use the equation that only has those four pieces of information. I'm going to use my Sn is equal to R times Tn minus T1 all over R minus 1, because I can sub in all the other values. -104,858 is equal to -4 times Tn minus -2, all divided by -4 minus 1. And I'm just going to rearrange my formula to solve for what Tn is. So when I combine my denominator, I'm going to get -4 minus 1 is -5. And I'm going to multiply that into both sides to move it out. On the right side, I have -4 Tn's, and the minus -2 is going to be the same as +2. When I solve this on the left-hand side, I'm going to get positive 524,290 is equal to -4 Tn's plus 2. And at this rate, the process is pretty simple. I'm going to subtract 2 from each side. 288 is equal to -4 Tn's, and I'm going to divide both sides by 4, and that final term value is going to be -131,072. For example 5, it says a geometric sequence, the fifth term is 1,024, and the common ratio is 4. Find the sum of the first 7 terms in the sequence. I list out what I know. I know that T5 is equal to 1,024. I know that R is equal to 4. I don't know what T1 is, but I can solve T1 with this information using my geometric sequence formula. If Tn is equal to T1 times R to the power of n minus 1, then in this case, 1,024 is equal to T1 times 4 to the power of 5 minus 1. Or T1 would equal 1,024 divided by 4 to the power of 4, which gives me a first term value of just 4. If it wants to know the sum of the first 7 terms, the sum of the first 7 terms, when I don't know the value of the last term, is going to be 4 times 4 to the power of 7 minus 1 all over 4 minus 1. The sum of the first 7 terms is 21,844. I can determine the number of terms in a geometric series by stating if I want to solve an equation with a common base, then I'm going to say that my first term value is 5, my common ratio is 15 divided by 5 or 3, my Sn is equal to 16,400, or the sum of all those. And if I said that 16,400 is equal to 5 times 3 to the power of n, which I don't know, minus 1, all over 3 minus 1, then I would take 3 minus 1, which is going to give me 2, and I multiply that into both sides. 32,800 is equal to 5 times 3n minus 1. I'm going to divide both sides by 5 and say that 6,560 is equal to 3 to the power of n minus 1. I'm going to add 1 to both sides. 6,561 is equal to 3 to the power of n. And then I could expand it out in order to figure out 3 to the power of what is equal to 6561. 3 to the power of 8 is 6561. So n is equal to 8. I can also do this using the intersect feature on my graphing calculator by saying y1 is equal to the left side, y2 is equal to the right side, 5 times 3 to the power of x minus 1 over 3 minus 1. And then I'm going to solve the x value at the intersect point, which will also give me 8.